Hey everyone, and welcome to this explainer on the beautiful, completely baffling mysteries of the conscious brain. We're going to skip the usual intro today because I want to jump straight into a fascinating medical mystery. It's the story of a man named Henry Molaison. Right around his 15th birthday, Henry started suffering from these incredibly severe, frequent epileptic seizures. Faced with a pretty bleak future of violent convulsions, Henry agreed to a radically experimental surgery. Doctors actually went in and removed the middle part of his temporal lobe on both sides of his brain, which crucially included a little seahorse-shaped structure called the hippocampus. Now the good news? Henry was totally cured of his seizures. The devastating news? For the rest of his life, he completely lost the ability to form any new memories. But the story doesn't actually end there. The true mystery is what else Henry lost along with his past.
Okay, let's dive into this by trying a little experiment together. I want you to actively engage with this for a second. Close your eyes if you need to, and just picture what it would be like to go to the beach tomorrow. What exactly are you conjuring up in your mind right now? Are you seeing kids building sandcastles? Maybe some surfers out catching a wave? You can probably almost feel the heat of the sun, right? Or hear the crashing waves. What you're doing is running an incredibly rich, multidimensional simulation inside your head of a future that hasn't even happened yet.
But if you were to ask Henry what he imagined for his trip to the beach tomorrow, his typical response was just a blank blue screen. He would literally say, "All I can come up with is the color blue." And this is just wild because it brilliantly illustrates a profound revelation about our neurobiology. Since Henry's surgery prevented him from forming new memories of his past, he also completely lost the ability to project forward and imagine his future. It turns out those two abilities are inextricably linked.
So the absolutely crucial takeaway here is that memory is not at all what we traditionally thought it was. For decades, we basically assumed memory was just a video camera, passively recording everything so we can hit play on our past later on. But Henry's condition proves memory is actually way more like a time machine. The hippocampus doesn't just store old footage, it actively uses that footage to assemble our imagined future. It takes bits and pieces of what we've already lived, the smell of salt water, the texture of sand, the warmth of the sun, and recombines them so we can travel forward and plan our tomorrow. It's literally a biological time machine.
So let's see how this builds into our broader understanding of the aging brain. To put things into perspective, back in 1994, Dr. David Bennett started the Religious Orders Study at Rush University. They tracked 1,100 entirely symptom-free nuns, priests, and brothers who were all over the age of 65. Because their daily lifestyles were so rigidly similar, they were literally the perfect candidates for isolating the real risk factors of aging. Researchers tracked their cognition for years and eventually collected and examined over 350 of their carefully preserved brains after they passed away, specifically looking for microscopic evidence of disease.
Well, Dr. Bennett's team made a shocking discovery when they finally looked at those brains. They found that some participants died with full-blown Alzheimer's pathology, like their brain tissue was completely riddled with the disease. And yet, while they were alive, they showed absolutely zero cognitive decline, no memory loss, no confusion, nothing. How on earth is that possible? It all comes down to something called cognitive reserve. Think of the brain like a toolbox. If you have a well-stocked toolbox, you've got options, right? If a disease destroys your ratchet, no problem. Your brain simply reaches into the toolbox and pulls out a wrench to get the job done. If the wrench is missing, it grabs some pliers. The nuns who showed no symptoms had built such an impressive cognitive reserve that their brains had simply constructed alternate neural pathways, bypassing the damaged tissue entirely. Which naturally begs the question, what does this mean for us? How do you actually build this reserve for yourself? Well, the data showed very clear protective factors. Cognitive exercise, doing things like crosswords, reading, learning a totally novel skill is incredibly protective. So is staying socially active and physically fit. Essentially, anything that forces your brain to build brand new neural roadways from point A to point B. On the flip side though, we have to be really cautious because negative psychological factors like chronic loneliness, anxiety, depression, and distress were linked to a much more rapid cognitive decline. We obviously can't stop the clock on aging, but by deliberately practicing these protective skills, we can absolutely stock our cognitive toolbox and hold on to who we are for a lot longer.
Okay, so we've seen how we protect the physical hardware of the brain, but that brings us to an even deeper mystery. How do we actually experience it? When you think about who you are, the most undeniable fact is that you're a sentient being. You feel like you're looking out at a technicolor world from your own personal center stage. We call this consciousness. But consciousness isn't a permanent state, right? So I want to ask you, what actually differentiates our conscious, sentient awareness from the total, absolute nothingness of deep sleep? Well, we can measure this using an EEG, which picks up the electrical signals of billions of your neurons firing. And this brings us to an incredible analogy, the stadium of neurons. When you're awake, your brain waves show that your billions of neurons are engaging in thousands of discrete, complex, independent rhythms. It's exactly like being in a packed sports stadium where thousands of separate, nuanced conversations are happening all at once. That sheer complexity is what creates the conscious you. But what happens when you enter deep, slow-wave sleep? The brain doesn't just shut off, it's actually just as active, but instead of complex conversations, the neurons enter a highly synchronized rhythm. Imagine that packed stadium suddenly stopping their individual chats to do one continuous, relentless Mexican wave. In that simplistic synchronization, consciousness vanishes. You just disappear into nothingness until the wave finally breaks the next morning and your complex conversations start back up again.
This leads us right into one of the most baffling puzzles in modern neuroscience, the mind-body problem. How does physical, biological neural activity actually create the experience of a mind? The famous philosopher René Descartes tried to solve this by assuming, incorrectly it turns out, that an immaterial soul existed entirely separately from our physical body. He speculated that sensory input came into the brain and interacted with this ghost-like spirit through a tiny structure right on the brain's midline called the pineal gland. It's an elegant idea, honestly, and it's super easy to imagine our soul as something completely separate from our wet biology. But if Descartes had the chance to walk through a modern neurology ward today, he would have seen very quickly that the mental is completely inseparable from the physical. When a physical brain changes, the core personality of the person changes right along with it. Depending on exactly where brain damage occurs, a person can suddenly become severely depressed or wildly manic. It can completely alter a person's religiosity, change their unique sense of humor, or even create a sudden appetite for gambling. It can literally turn a decisive person into an indecisive one, or a peaceful person into an aggressive one. Who you are at your very core is entirely dependent on what your physical neurons are doing, moment by moment.
And yet, even knowing that the physical brain creates the mind, that still doesn't fully answer the deepest question. I absolutely love this story about Francis Crick, the famous scientist who helped discover the structure of DNA. Well, later in his career, he turned his brilliant mind to the problem of consciousness. On his office chalkboard, surrounded by all these complex scientific equations, he kept one single word written huge in the very center: meaning. Because this is where science still hits a massive brick wall. We know how neurons fire, we know how brain regions connect, but we still have absolutely no idea why these physical electrical signals coursing around in the dark of our skulls cause us to actually care about anything. We literally don't know how biological matter generates meaning. While we definitely don't have the full answer to Crick's question yet, we do know that meaning is deeply tied to a massive web of unique, personal associations formed by your entire history of life experiences. Let me demonstrate what I mean here. Imagine I were to take a plain piece of cloth, smear some random colored pigments on it, and hold it up to your visual system. Is that raw physical input really going to trigger deep emotions or fire up your imagination? Probably not, right? It's just cloth and dye.
But imagine those exact same colored pigments are arranged into the specific pattern of your national flag. Instantly, that visual input triggers something powerful in you. It brings up pride or history or memory. But here's the real kicker. A dog looking at those exact same pigments wouldn't appreciate any meaningful difference between the flag and a random smear of paint. The meaning isn't in the object itself. The meaning is entirely in you. This beautifully proves that you don't perceive objects as they are in reality. Rather, you perceive them as you are.
Every single one of us is on a totally unique trajectory, steered by our specific genetics and our highly specific life experiences. Because of this, every single brain has a completely different internal life. From cradle to grave, your trillions of neural connections are continuously forming, reforming, strengthening, and breaking. Your brain is quite literally a constant work in progress, and this means that brains really are like snowflakes. Because of this unimaginably complex and shifting pattern, no one exactly like you has ever existed in the history of the universe, and no one exactly like you will ever exist again.
You are a beautifully unique, ever-changing, conscious pattern of neural rhythms. When you learn something new today, when you build that cognitive reserve we talked about, when you wake up from the synchronized wave of sleep tomorrow morning, you are physically a slightly different person than you were yesterday. Because you are always changing, so is absolutely everything you see and experience. So I want to leave you with one final, provocative thought to contemplate today. Since you are not fixed and the world you experience is just a reflection of your own neural webbing, there really is only one question that matters. What will your neurons do next?